In this video, we'll explore law of sines and its applications. First off, let's talk about what law of sines is. As you can see right here, we've got a triangle, not necessarily a right triangle. Law of sines will apply to any triangle, which makes it very beneficial. It's how we can apply trigonometry beyond just right triangles. Within our figure here, the red letters will denote our angles, also being capital letters, and then the blue will represent our sides. So take note that little a is across from angle A. So law of sines states that if you take the ratio, if I have sine of big A divided by its opposite side, little a, that ratio is going to be the same as if I take sine of big B divided by the side length, little b. And then likewise, I can use this same idea for the sine of big C divided by its opposite side, little c. Now in practice, you'd only use two of these at once, but this ratio will hold true regardless of what angles you're looking at. So let's take a look at an example here. Right here we're given two angles, one side, and we're asked to find the opposite side of the 60-degree angle, x. Well, to set this up first, we can use the knowledge that 60 is across from the x. We can say the sine of 60 degrees, which is just a number. If we go to our calculator, we can calculate that. Divided by x has to be equal to the sine of 78 divided by 8. Now noticing that we have a proportion here, we can cross multiply and get x times the sine of 78 degrees must be equal to 8 times the sine of 60. Furthermore, we can divide both sides by the sine of 78. And then x has to be equal to 8 times the sine of 60 degrees divided by the sine of 78 degrees. Which, if we run this into our calculator, we get roughly that x has to be equal to 7.08 units. Let's go ahead and look at another example. Instead, this time, let's use law of sines to solve for an angle. In this case, the angle we're looking for is denoted with an x, and we know that the side across from it is the 14. So if I have sine of x divided by 14, I know that has to be equal to the ratio of the sine of 63 divided by its opposite side, 12.5. Now, applying same procedure here, we can cross multiply, so we get 14 times the sine of 63 has to be equal to 12.5 times the sine of x. Now I'm trying to get x by itself, so the first thing I'm going to do is divide both sides by 12.5. So if I take 14 sine of 63 divided by 12.5, I know that this has to be equal to the sine of x. Now, much like when we were doing right triangle trigonometry, we can apply the same idea here. I know what sine of x is, but to undo the sine, I have to apply the inverse. So, if this is the sine of x, then x has to be equal to the sine inverse of 14 sine of 63, all divided by 12.5. And if we punch this into our calculator, we get roughly that x has to equal 86.31 degrees. There's a couple examples of how to use law of sines. It's fairly simple other than the trigonometry. Just be very careful with your calculators when you punch into things. Make sure your parentheses in the right spot. Break it up into pieces if you need to. But there's the concept. Good luck.